8.5, write and graph exponential growth functions.
This sounds confusing.
And I bet you would never guess, but tomorrow we're going to be graphing decay functions.
No, thank you. Okay.
Isn't decay like dead?
That's a lie.
Exponential functions.
No, decay from like kids like
They're of the form y equals a b to the x, where you don't need graph paper. A is not equal to 0, and b is greater than 0, and b is not equal to 1. These are non-linear functions.
This don't even work. Is it lagging?
Yeah.
Maybe hold it like straight up and down. Exponential growth. Y equals ab to the x when a is greater than 0 and b is greater than 1. Are you struggling?
Something like that.
Should have had a free day.
Not gonna solve the problem.
What would be? Or what?
Yeah. Exponential growth model.
Wait, what are we reading today?
Your book.
I don't like them.
Y equals a times 1 plus r to the t, where y is the final amount, a is the initial amount, r is the growth rate as a decimal,
No.
1 plus r is the growth factor,
Big old hen, big old hay.
and t is the time period.
Does that say growth or growth? Growth.
What?
It says growth. The purple is
Growth?
It says growth.
No, I can't see.
Just try out every desk and pick your favorite one.
Oh, Sean, I can't see from there.
Okay.
Now I can't see the door.
Good one, Dylan.
All right, in exponential, that was a fun color, exponential growth graph. The domain of it is all real numbers, or we would say from negative infinity to positive infinity. And the range is from 0 to infinity.
What's that like first thing after E?
It's a 2-line R, means all real numbers.
Something funny? Yeah.
So an exponential growth graph is going to look like this. Well, I'm not done
How
yet.
do you draw that?
You don't know how to draw a graph?
No.
An exponential growth graph looks like that.
No, no.
No. Should we do it like a different color?
It never crosses the x-axis, and it goes, basically it gets closer and closer, never touches, and then goes up to infinity. a sideways 8?
Just turn your page.
So just draw 2 circles. That does not look like an infinite
Or you could just, you know.
You said this was easy.
sign. How?
We haven't even done a problem yet. Like,
You said this was
it is easy.
Just look at it. There's different numbers. There's A's. There's B's. There's eights. There's
Oh, I
This
get
is
it.
just the domain and range. You're not even, like, putting that for any of the questions. I'm just, like, letting you know that that's information. I'm not, like, asking you to do that part. Graph the function and identify its domain and range. We're just graphing the function. It's nice and easy. Number 10. Y equals 7 raised to the x.
How do I do this? Oh, wait.
Do you want to come teach then, or?
No.
Okay.
Yo, Drew, I've done that before. It ain't worth it.
All right, I'm going to make a table. And I'm going to choose values. It might blow your mind, but I'm going to choose -1, 0,
Not.
and 1. So then, everywhere I see an x, which is just in the exponent, I'm going to replace it with each of these numbers. So I have 7 to the -1, 7 to the 0, and 7 to the 1. What is 7 raised to the -1?
-7.
1 over 7.
Oh, yeah.
What is 7 to the 0?
1.
1. What's 7 to the 1? 7. Now, I'm going to set up a little graph. Just goes from -1 to 1 on the x-axis, and then I'm going to go up to 7 on the y. At -1, it's 1/7, so I'm going to go just a little bit above the axis there. At 0, it's 1, so I'm going to put a point there. And then at 1, it's 7. And then, whoops. It's a lot harder to do this on the iPad than it is to do this on paper. And it looks like that.
That's all you do.
Yep.
That's so hard.
What are you confused about?
How do you graph 1/7? Yeah.
It's just a little bit bigger than 0, so I just put it above the line a little bit.
Alright. Okay. We can do homework now. Yeah.
Why are y'all like so anxious to like not do work?
Because this has been a very stressful week.
It's the first day.
I mean, last week. Last week's been very stressful.
See, by doing work now, though, maybe later in the week we can have a chill day.
Yes. Oh, yeah.
Like Wednesday.
After the quiz?
We have to take a quiz Wednesday.
Yeah, that was the whole thing I was saying about us doing stuff today.
Where have you been, Sean?
I mean, I know Drew was on the floor crying, but... All right, do the same thing here. So I'm going to set up my little table. And the table is semi-optional for these ones that are just like a whole number raised to a power. When we get to fractions, you need to make sure you do the table. But I'm going to go -1, 0, and 1. Now, I could go bigger numbers, but I'm telling you that in most cases, these are the easier ones to do. So, I'm going to have 9 to the -1, which is 1 over 9. I'm going to have 9 to the 0, which is 1. And I'm going to have 9 to the 1, which is 9. And then I'm going to set up my graph again.
This is easy. Those notes we took before made it look like it was going to be really hard.
All right, so at -1, it's 1/9, so I'm going just above the line. At 0, it's 1. And at 1, it's 9. And then you just connect it.
Or does it get any more hard?
A little, but not by much.
Why do we do the fractions one? But in this lesson, does it get harder in the other lessons?
Yes.
What? Yes,
Yeah, it's gonna get a little harder in this one, and then the next lesson is just the inverse of this. So instead of them being positive, they're gonna be like, or like instead of them being whole numbers, they're gonna be fractions.
No. Fractions and fractions.
I think I've had enough math.
Y equals 7/2 to the x.
What?
What? I thought you said that was the X lesson.
What?
Like 1/9. Never mind. You'll see in a second. All right, XY table. So I'm plugging in these values here for x. So this is 7/2 to the -1. What does that do? It's going to flip it, so it'll be 2/7. It does technically get distributed on both things, but it causes the whole thing to flip. And then I have 7/2 to the 0. That's 1. And then I have 7/2 to the 1, which is approximately what?
6.5. No, 3.5.
3.5. I only really care about that for the sake of graphing. So I'm going to just go up to 4 on this one. So at -1, it's 2/7. So again, it's just a really small number. At 0, it's 1. And at 1, it's basically 3.5.
So all the graphs are the same.
Yes.
Alright, that's easy. Let's do homework.
So pretty much I could just write down the numbers and then just make it work.
Well, I mean, it's got to be where they're supposed to be.
Is there ever going to be like one that's like on the other side?
Yes. 22. Y equals 2 times 3 to the x.
What? So do we multiply?
I told you we weren't done.
So do we multiply it first?
Nope.
Is it?
PEMDAS. Exponents come first. So I'm still going to set up a table. I'm just probably going to need a little more space in my middle box. Oh, that's exciting. My iPad's about to die.
Yes! Yes! Oh no, she
Can't
doesn't
do
charge her
words,
guys.
man.
Y'all think I'm unprepared?
I wish.
Okay. All right, so I'm going to plug in still -1, 0, and 1. I don't know where that random line just came from. It was exciting. All right, so when I do this, I have 2 times 3 to the negative 1. Well, what's 3 to the negative 1? 1/3. So this is 2 times 1 over 3, which is 2/3. When I plug in 0, I have 2 times 3 to the 0, which is 2 times 1, which is 2. And then when I plug in 1, I have 2 times 3 to the 1, which is just 2 times 3, which is 6. So it's going to basically look the same. I've got negative, at negative 1 it's 2/3, so it's going to be a little higher up this time. At 0 it's at 2. And then at 1 it's up at 6. So the graph still looks the same, but notice the points are different. So what I'm really looking for here is that you've shown me what the points are that you're going to plot, and then that you've plotted those 3 points. Okay, and that's basically all I'm looking for as far as like the graphs. Like, I'm not getting super picky about it. When you get into Algebra 2, Pre-Cal, those kinds of things, I am going to get more picky about these. But these are just like the baseline, like the easiest of easy problems for this stuff that you need to be able to do. 24. This thing is like glitching. Oh, what's happening? Y equals 1/4 times 3 to the x. So I'm going to set up my table again. Still going with negative 1, 0, and 1. So I've got 1/4 times 3 to the negative 1. 3 to the negative 1 is?
1/3.
So this is 1/4 times 1/3. 1/12. And then I've got 1/4 times 3 to the 0. So 1/4 times 1, which is 1/4. And then I've got 1/4 times 3 to the 1. 3/4. Now, all of these numbers down here are less than 1, right? So, what I would recommend when you graph these, just so that it's easier to see, is I would draw one like way up here this time instead of it being like way down low, so that you can actually see the whole graph. Is it wrong if you don't do that? No, I'm just doing it so it's easier for you to see. All right, so 1/12 is still going to be just a little bit above. At 0, it's 1/4, so I'm going about 1/4 of the way up. And then at 1, it's 3/4, so I'm going 3/4 of the way up. So this graph looks the same. I don't know why this is glitching so bad. You gonna make it?
Today is actually like pretty crappy, not gonna lie.
Why is that?
I don't know, I'm just like tired after that. Everything's hurting, bro. My knee felt like it had a crack, and then the crack like faded away.
What are we complaining about?
I don't know. That's it. Wait, we're done? I mean, like, it could be worse, but like, it could be. I feel like that's what we always get for like every. No, I never had so.
9, 19, 23, 25, and 29. Now, I'm going to tell you something about 29. I didn't do one like this one, but I want you to try it because I'm going to see if you're paying attention. The graph will not look like this because it's negative. It's going to look different. So remind me and we'll go over that one tomorrow. Okay.